Okay, so now we will be discussing the power property, which you use for x raised to any number, pretty much, and for polynomials. So a power is defined as x raised to some number. There's the general form of it. And then for the power property, if f of x equals x to the n, f prime of x equals n times x to the n minus 1. And then for polynomials, you do the same thing, except you would just add or subtract the derivatives of each of the individual powers, which you'll see better on the next screen. But if there's a constant, example 4 times x squared, you just multiply the constant by the derivative. So you'll see that on the next page as well. Okay, so for the first one here, that should be squared, not just 2. So 3x squared. So what we do using this is if you remember from the last slide, we just multiply the constant out, so 3 times, and then multiply it by this. So n is the 2, so we do 3 times 2, x, 2 minus 1. So that equals 6x, and then 2 minus 1 is 1, so we just leave that blank there. So the derivative of 3x squared equals 6x. For the next one here, this is a polynomial, so we do the same thing except we just subtract or add each of the individual derivatives. So we'll start here. So it's a constant, so we multiply it out. N, we drop down, x, 4 minus 1, and I'll put that in parentheses, so we know that that's the first one, minus 2 times 3x, 3 minus 1, there's our second one, plus, there's no constant here, so we just don't worry about that, but we drop down the 2x, 2 minus 1, and then this, what this is really is just x to 0, because x to 0 is 1, and so the derivative of just a number such as 1 is just 0, so we don't put anything there. So to show you another example of that, say we have f of x equals 4, the derivative of that is just 0. Because if you look at the graph of it, so 1, 2, 3, 4, it's just a straight line. So at any given point, the derivative is always going to be 0, because if you recall when we had like a quadratic or something like that, to graph the derivative of this, we took the slopes of each point. This is always just 0. So that's why when you have just a constant, the derivative of that is 0. But back to the original problem. So to simplify it further, 4 times 4 is 16, x to the 4 minus 1, which is 3, minus 2 times 3 is 6, x squared, plus 2x. So that is the derivative of f of x. And that is the derivative there. So in the next lesson, we will be discussing the rule for exponential functions. So that's when the x is in the power, I guess you could say. So let me, 1 second. So for exponentials, which we'll be discussing next, that's when you have a number raised to the x. So a being just any number raised to the x. So that's what we'll be covering next.